remember back to your pre-algebra or before days, or maybe you wanted to forget, how do we add and subtract fractions? So just a quick review. If you're multiplying fractions, right? If my thing will let me type on here. You can do it. There we go. So if you're multiplying fractions, right? If you have A over B times C over D. When you're multiplying fractions, you actually just multiply the numerator. So you do A times C, and then you multiply the denominator over B times D. So multiplying is actually pretty easy, right? Because you don't have to make sure anything's the same. You just multiply across the top, multiply across the bottom, and you're good to go. Dividing's a little trickier. So this is kind of a review of 6.2 and 6.3. So if I have A over B, that's supposed to be a B, divided by C over D. I don't quite know how to divide fractions, but I know that instead of dividing a fraction, I can multiply by the reciprocal. So it's A over B times, and the reciprocal is D over C. So you flip the second fraction, that's called the reciprocal, and then it becomes a multiplication problem, and then we do the same thing, right? A times D, multiply the top, B times C, and voila, you've solved it. So now in section 6.5, we're getting to adding and subtracting fractions. So I don't know if you remember this, but a long time ago, you probably had problems like this. 3/4 plus 1/2. And then you'd have to add the fraction together, right? Well, when it comes to adding and subtracting fractions, it's actually not as easy as multiplying and dividing, right? Because in order to add or subtract fractions, we have to have the same denominator. So this is going to hold true for algebra too, right? We have to have the same denominator in order to add or subtract fractions. So right now, one of these has a denominator of 2, and one has a denominator of 4, and we need to make them have the same denominator. And we can do that by either reducing one of the fractions or enlarging the other fraction, basically doing a multiple of that. So what I mean by that is instead of writing 1/2, we can multiply 1/2 by 2 over 2. Now, why can we just randomly multiply one thing by a number? Well, 2 over 2 is just 1, really, right? So we can multiply anything by 1. But what happens when we multiply 1/2 by 2 over 2 is that we end up with 1 times 2 is 2. 2 times 2 is 4. So now we have 3/4 plus 2/4, and now we have the same denominator. And when you add fractions, you add the top, right? So we're going to do 3 plus 2, but the denominator stays the same. The denominator stays 4, whatever it was before. So we'll end up with 5/4 or 1 1/4. Okay, so that's kind of a review of fractions, but basically we're going to do the same thing, except we're going to throw some variables in there. Okay, but the same rules apply. If you want to add or subtract a fraction, you have to have the same denominator, and sometimes you don't have the same denominator, and you have to use some tools to make the denominators the same. So you guys kind of remember that? Somewhere back in the memories. Yep. Awesome. Okay, so I have a couple examples here on the paper, and then we'll do a few more from your book just to make sure that we're good. Let's actually start with example number 2. So you have x over x plus 3 plus 4 over x plus 3. So the first thing that you're going to want to do for these problems is to check and see if they have the same denominator. And guess what? These actually do. They both have a denominator of x plus 3. So my new fraction, when I add them together, is going to have a denominator of x plus 3. If I can write a plus, x plus 3. The denominator stays the same. And then my numerator, I just add each of these together. So it's x plus, or x, yeah, x plus 4. So pretty easy, right? Not too bad. So far. You're like, but wait, there's always more, right? Okay. Now, that's why I waited on number 1, because number 1, adding is always easier than subtracting, right? You don't have to worry about negative numbers and all that stuff. Number 1 is a subtraction problem. Okay, so let's talk about this guy a little bit. We have 4y divided by 9 minus 3y minus 1, okay, over 9, excuse me. So do they have the same denominator? They both share a denominator of 9, right? So that's good because we don't have to deal with that. So we know that the denominator is going to be 9. So now we just have to deal with subtracting the numerators. And this is the one part that can trip people up. So we have 4y, that's good, right? 4y minus, this is a subtraction problem, right? This is where people get tripped up. You're subtracting everything that's in the second fraction. So you really need to think of that second fraction as being in parentheses, because you're not just subtracting 3y, you're also subtracting minus 1. Okay, so this part right here is where you want to pay attention. Make sure you subtract everything that's in the second part of the equation. So what that means is if I rewrite this, 4y just stays the same, right? This subtraction applies to both items. And different people do this different way. The way I taught my son is he actually writes it as, if I can write it up here, 4y plus negative 1 times 3y minus 1, and distributes that way. Or you can just know that you need to distribute your subtraction to each thing. Either way is all right. But what you'll end up with is 4y minus 3y, and then you're subtract 1. So minus a minus 1 is add 1. So over 9, 4y minus 3y is y. So you end up with y plus 1 divided by 9. So that's the tricky part when it comes to subtraction. So let's try number 7 in your homework. So sorry, random number. It's going to mess up your homework, right, guys? Let's try number 7. And I'd like you guys to try it too. Like, I'll write it up here. Go ahead and start trying it, and then I'll give you a minute or two to get through it. So number 7 is y minus 3 divided by 4 minus 3y minus 5 over 4. All right, so you guys try this. We're good on one aspect because they both have a denominator of 4, so that's really good. So you guys try that for a minute, and then I'll jump in and start. Got it? All right, I'm going to go ahead and get started on this one. Sophia, and I'm thinking Olivia and Jack, if you guys are working on it. We'll just get started. Okay. Oh, you're finished. Okay, cool. I think it's Olivia. I don't know. I see participant 3 and 4 and okay. When you try to use the mic, it crashed. Well, don't use the mic then. Sorry. But welcome. I see you're here. Okay, so 4 and 4 are common denominators. So that's good. We don't have to deal with the denominator, right? So it's going to be 4. And we have y minus 3. And you can put that in parentheses if you want. Minus 3y minus 5. Okay, so this subtraction is going to apply to both of these terms. All right, so y minus 3 just stays the same. And then it's going to be minus 3y. And then it's going to be minus 5. So when you're subtracting a negative, you're adding 5 over 4. Okay, so y minus 3y is minus 2y. And negative 3 plus 5 is positive 2 over 4. Did it? Nice. Yay. Now, if you go to look at your, if you go to look at the solutions in the back of the book, it's actually not going to look like this. Does anybody know why? Because there's a 2 and a 2 in here. So they actually made it even more simple. So they said, oh, we're going to pull a 2 out and make this 2 and then minus y plus 1 over 4. And then 2 and 4 can kind of cancel each other out. So their solution is this. But as long as you get to here, that's the important part. Okay. So not too many of them have simplified. That particular one just was simplified, but not too many of them have that. Okay, so let me do let's do a few more that get a little bit more complicated, but not overly complicated. So if you look at number, and I think you guys should be able to figure this one out. If I have number 17, sorry, I'm skipping everywhere. All right, which is 2 over x plus 3 over x squared. And I wanted you to add those two together. Okay, do they have the same denominator? So these two actually don't have the same denominator because one is x and one is x squared. So we have to make them have the same denominator. Oh, and we can't just magically do that, right? One is just a plain old x and one is x times x. So what do we have to do to this one to make it into x squared, to make them have the same denominator? We would need to multiply. So I'm looking at this first fraction. We need to multiply this bottom denominator by x, right? To get an x squared. But we can't just randomly multiply things. But what if I multiplied this whole fraction by x over x? That seems really weird, right? X over x is just 1. So we can multiply by 1, no problem. But when I multiply by x over x, this becomes 2x divided by x squared plus 3 divided by x squared. So now I have x squared the same in the numerator and the denominator. So now can I solve this? Yeah, right? I just keep my denominator is x squared. This is an easy one. And I do 3x or 2x plus 3. 2x plus 3. Yeah, so you can't actually write this as 5x because the 3 doesn't have an x. So this would be as simple as we could get because I can't combine those two together. It's a good question. All right, so we're going to use that tactic a lot. So this is not one on your paper or one on your homework, but I'm going to do 22. I just want to do a lot of examples so you're feeling comfortable with us. So I'll do this one quickly. 2x over x minus 3 minus 3 over 2 times x minus 3. Okay, so they do not have the same denominator, right? One has a denominator of x minus 3, and one has a denominator of 2 times x minus 3. So how am I going to force them to have the same denominator? Well, I'm going to see, okay, they both have x minus 3 in common, but this is multiplied by 2. So I can make them have the same denominator if I multiply my other fraction by 2. But I can't just randomly multiply by 2. I also have to multiply the numerator by 2 because this is just like multiplying by 1. And I'm allowed to multiply anything by 1. So this becomes 2 times 2x, so 4x. And the bottom becomes 2 times x minus 3 minus 3, 2 times x minus 3. So now I have the same denominator. So it's 2 times x minus 3. And the top is 4x minus 3. So question, can I cross out 2 and 4 like that? So the answer is no, you can't. Yeah, don't do it. Yeah, no, it's okay. So you can't because this 4 belongs to this x. The only way you could cross it off if it was like 4 times x minus 3. So if it was out front being multiplied by everything, then you could cross them off. But the way this is written, this is as simple as it gets. Okay. So let's see. That just sounded like I was singing. I was going to say one more. Let's do 2 more, and then we'll get to the last section. Okay, so just sometime today. It can be later. Sure. I hope you're not up Friday night doing your algebra test, though. What's that? Yeah. Yeah. If you're like, Yeah. I hope that you're not sending it to me at midnight. Just for your sake. Okay. Let's do 2 more examples. So this is number 25. See if you guys can figure this out. So we have a denominator of 6 and a denominator of 9. Obviously, the denominators are not the same, so we can't subtract yet. What can we turn 6 into 9 or 9 into 6? Yeah, they both have a factor of 3, right? But I can't really reduce either of them. Yeah. So what I haven't been actually saying and calling it is we have to use that that LCM, the least common multiple. Do you remember that rule a long time ago? Or lowest common denominator. There's different terminology for it. Basically, we got to come up with a denominator that works for both of them. So far, we've had denominators that are already the same. That's awesome. We've had denominators where we have to change one into the other, but sometimes we just can't change one into the other. Like we can't make 6 turn into 9 without multiplying by a fraction, and nobody wants to multiply by a fraction, right? So if I look at 6 and 9, my lowest common denominator for both of those is going to be 6 times 3 is 18, right? And 9 times 2 is 18. So I could change both of these to a denominator of 18. And then I will have fractions that are the same. So I actually have to transform both. So first I'm going to look at my first, like you're going to treat this one first, right? So I have 3y minus 2 over 6. And how am I going to turn that into 18? I have to multiply 6 times 3, right? And I also have to multiply the top by 3 because I can't just randomly, multiply by 3. This is like multiplying by 1. Okay, minus, now my second one is y minus 3 over 9. So what should I multiply this by to get a denominator of 18? Uh-huh. And it should be, right, 2 over 2, right, Sophia? So that's just like multiplying by 1, and I'm always allowed to multiply by 1. So now this is really just a huge simplifying problem, right? I've got to multiply 3 times everything in here. So it's 9y minus 6 over 18 minus, don't forget to distribute, right? 2y minus, nope, 6 minus 6, 2 times 3, over 9. Nope, over 18. Apparently my brain's on vacation already. All right, so now I have a denominator of 18. So I have 9y minus 6 minus 2y minus 6. And I end up with 7y minus 6. Oh, it's just 7y over 18. So that one makes sense? Kind of. That's the hardest one. What's that? Oh, I did 9y minus 2y. Yep. And then the other one is actually minus 6 minus a negative 6. So it's basically minus 6 plus 6, and they cancel each other out. Okay, so then we just have 6, 6 left, which is actually really similar to 6, 5. Okay, it's called mixed expressions. So I actually think this is really similar to what we were just doing. So let me show you an example of this. So let's do number 3. I actually think this is in 6-6, so I'm on page 271. I have 8, 1 over x. Okay. So this is in 6-6. 6-6. So you might be tempted to say, oh, this is 8 over 1. You just combine them together. But that's not right. Don't do that. Okay. When you look at a number like 8, you don't normally think, at least I don't automatically think of it as a fraction all the time, but it actually is a fraction, right? This is 8 over 1 plus 1 over x. So can I add these together like they're written? No, right? Because I have a 1 in the one denominator and an x in the other denominator. So I need to find the lowest common denominator of 1 and x. Well, the lowest common denominator of 1 and x is x. So I need to change 8 over 1 into 8 over x somehow. So how am I going to do that? Well, what I can do is I can multiply 8 over 1 times x over x. X over x, remember, is just 1. So I'm allowed to multiply that. So I can change my first 8 into 8x divided by x, right? And if you notice, like if you're into simplifying, oh, 8x divided by x is just 8. But we don't want it like that. We want it to stay 8x over x plus 1 over x. Now I have the same denominator, and I just need to add my numerator. So 8x plus 1 over x. So I feel like it's really similar to 6.5, right? You have to make the denominators the same. But in this case, all of the denominators of one of them are just going to be a whole number. Okay, so I'm going to let you guys try, or at least get started on number 5, and then we'll talk about it. So we've got number 5 is 3a minus 2 divided by a. And the hint I will give you is make sure you just go like that. So when you see just a random 3a minus 2, right, just think, oh, I'm dealing with fractions. I might as well put it over 1. All right, so I'll give you 2 minutes to try that one. Nice. Wow, you guys are speedy. Awesome. Okay, so we got to make this one have a base of a, or a denominator of a, right? So in order to do that, we're going to multiply by a over a, which is just like multiplying by 1. I know I've said that a million times, but it's just like multiplying by 1, right? So a times 3a is a squared, or 3a squared, and a times 1 is a, minus 2a. Now we just use our rules of adding. This is an a, so, or subtracting. So our denominator is a, and our numerator is 3a squared minus 2. Awesome. You guys are rock stars. Okay, so let's get a little more complicated because it always gets more complicated, right? Let me see what I assigned. Okay. They live in a loud house. It's all right. Um, that's right. She just wants to learn some algebra too. I am going to change your homework. So listen, this is important. Instead of 1 through 29 odd, I just want you to do 1 through 19 odd. Okay? Unless you really want to do through 29, but you don't have to. You'll probably do it. Okay, so let's get a little bit more tricky. I'll show you the example and then I'll have you do one from your homework, okay? So I'm going to do example number, or I'll do problem number 18. It's not in your homework. And then I'll let you guys try 19 because that's the hardest one, okay? But they should be really similar to each other. That's why I'm going to do 18. All right, 18 is 5a plus a minus 5 over 2a plus 3. Yikes. Okay, so I don't have the same denominator. I need to have the same denominator. It's nice that this denominator is 1 because I know in order to make it 2a plus 3, what I need to do, and this is completely okay, is multiply this fraction by 2a plus 3 over 2a plus 3. Okay, this is still, if I can make it right there, this is still 2a plus 3 over 2a plus 3 is still like multiplying by 1. So that's why we're allowed to do it. So now, this is where a little math work, right? The top is going to be 5a times 2a plus 3 over 2a plus 3 plus a minus 5 over 2a plus 3. Okay, I have to distribute my 5a, right? So I'm going to get 10a squared plus 15a. And then if you guys will let me do this, I'm going to go ahead and add this plus a minus 5 over 2a plus 3. So I end up with 10a squared plus 16a minus 5 over 2a plus 3. This looks like a total mess, right? But it's actually not that. We've used everything that we've known so far, basically kind of all thrown it together, but there's nothing super complicated about it. We're just multiplying by something to get the same denominator, distributing it, and then adding the terms together. So that being said, let's try number 19. I'll let you guys try it. Okay, so we have, good, 2a squared minus a minus 1 over 2a plus 5. This is 19. So go ahead and get started on that one. Let me know when you're done or stuck or Cool. Yeah, the answer has 4 terms in the top. All right, so I'm going to start kind of working this. If you are still working on it, it's okay. So we don't have the same denominator, right? We've got 2a plus 4, and then this is basically over 1. So I need to multiply. Should have left myself some room here. I'm going to erase number 19. Give myself some room over here. Wish you could do a bigger eraser. Okay. So what I'm going to do is I'm going to multiply this by 2a plus 1, or 2a plus 5. It'd be helpful if I multiply by the right thing, right? 2a plus 5. This is just 1, right? Really, this is just like multiplying by 1. I know I'm beating that point over and over again, but I just want you to realize that you're not just randomly multiplying things. You're just really multiplying by 1 is what you're doing. Okay, so then I need to write this out. So I've got 2a squared times 2a plus 5 over 2a plus 5 minus a minus 1 over 2a plus 5. All right, so first, you can decide whatever you want to do first. First, you could subtract it, so you could put this all in one big, huge 2a squared times 2a plus 5 minus a minus 1. So don't forget the subtraction is to the a and the minus 1, all over 2a plus 5. Okay, now in order to simplify this, I'm going to have to distribute it, right? So I'm going to get 2a squared times 2a is 4a cubed plus 2a squared times 5, so 10a squared minus a, because I've got my subtraction of a, and then subtract a negative 1 plus 1 divided by 2a plus 5. And I can't simplify any of this, so this is my final answer. Anybody end up with that? Or close? Awesome. Cool. All right. Well, that's all I have for you guys today. If you feel like you want to see another example from this section, I'm happy to stay on and do that. If you feel like you got it, then that's fine too. This again was number 19, so that's basically now you have to do 3 through 17 odd. But yeah, that's it. All right. Well, if I don't, well, I won't see you on Monday. So I'll see you in a week. I sent out an email with something to watch for next week, but class is canceled. So I will talk to you guys in about a week. All right. Thanks, guys. Take care. What's that? 512. Do you want to see some more examples from 512? Sure. Any particular one? 15? Okay. Let me flip my book back here. Dun, da, da, da. Okay. So this is s squared equals 4s plus 32, that one? Okay. So s squared equals 4s plus 32. Okay, so what the whole idea of 512 is that we are going, do you remember it's this whole, if something times something equals 0, then one of these two has to be 0, right? Looks like I'm drawing a weird smiley face. And so what we're trying to do is we're trying to get an equation that equals 0, and then we're going to try to get something times something equals 0. So the first thing that we want to do when we look at these problems is we want to say, okay, let's make this equal 0. So I can do that by, if I subtract 4s from both sides, I get s squared minus 4s. And then if I subtract 32 from both sides, minus 32 equals 0. Okay, so they kind of wrote it a weird way, but if you just move everything to the other side, we can make this equation equal 0. All right, so that's the first part, is we want some equation to equal 0. Now we're going to try to see if we can factor s squared minus 4s minus 32 in order to solve. So what I mean by that is we want to say, can something times something equal 0? So we've got s squared, right, which is s times s. And then we've got 32. What's all the ways we can make negative 32? 32 could be 2 and 16. That could be 4 and 6, right? 3 doesn't go into it. No, that's not right. 4 and 8, sorry. 4 and 8, right? So I think 4 and 8 might work because we want a 4 right here. So 8 times 4 is going to give me 32. One is going to be negative and one's going to be positive. So let's make that one negative, right? And let's make this one positive. And then we double check our FOIL off to the side, right? So if I FOIL this, I get s squared, outside is plus 4s minus 8s minus 32, or minus 4s. So that works out. All right, so all we've done so far is we changed our equation from written this way to written to equal 0, and now we've factored it to equal 0. Now is where we have to use this whole idea of something times something equals 0. So that means if my answer is 0, either s minus 8 has to equal 0, or s plus 4 has to equal 0. Okay, so then I just say, oh, well, that means add 8 to both sides. S has to be 8, or S has to be negative 4. These are the two solutions that make all of these equations true. Mm-hmm. Yep. Okay. If you get stuck though, send me a message because I am around today. So I leave tomorrow morning. So if you get stuck sometime today, send me a message and I'll help you out. All right. Will do. All right. We'll talk to you soon, Sophia. Bye.